All right, guys. We have his eye level is 50 feet from the tree. The triangle of interest is right here. 20 degrees is our reference angle. This is the opposite and the adjacent side. You look at SOHCAHTOA, and we decided that tangent is opposite over adjacent. This is just the generic form. Now you need to make it more specific. The tangent of 20 degrees is equal to the opposite over the adjacent. What is it? X over 50. Now what you're going to have to do is you're going to have to look up the tangent of 20 degrees. And there's a whole bunch of places where you can look. Your best option, at least for this class, is probably to grab your trig table and look up the tangent of 20 degrees. That's one way to look it up. And if we look up tangent, it's in this last column here. Sorry. I'll try it again. One other place you could look, guys, besides your calculator or your table, you could actually grab one of your trig books and look up 20 degrees in here. This tangent should be very similar. Let's see how close Caden got. Here's his. He had 3.3 over 9.1, which was 0.363. Pretty close? Within a thousandth is pretty darn close. I would be very surprised to get that close most of the time. Our final step, after we set it all up, we're going to put in the 0.364. How am I going to get the x by itself? Multiply by 50 on both sides. Now, I recommend putting this in another color, guys. Go ahead and multiply and find x. This is only going to be approximate because this is an approximation.
What?
And what did you get? 18.2 what? 50 times 0.364. 18.2 approximately what? Inches, trees, Santa Claus's feet. This is in feet. If you don't put units, guys, I will put units for you. Usually I'll choose dogs or cats or something more funnier.
Okay.
But anyway, if you don't put units, I will choose some randomly. Is this the height of the tree? Look at your diagram. Nope. How much higher, how much taller is your tree than that? 6 feet, because this is his eye level, isn't it? So you have to add the 6 to get the tree. The tree is actually approximately 24.2 feet. I do not think he's going to fit this one in his living room no matter how hard he tries. It's just not going to go. Now, follow the same steps with this one. This is a guy wire that's attached to a fruit tree. If you don't put support wires on fruit trees, as soon as the wind comes up, it'll knock them over. Because you can't pack down the earth around them. The roots will get ruined. And you have to put the support wires. I don't know if you guys have ever worked for a nursery or anything, but pretty much all new trees need support wires to hold them. They call this a guy wire. It's attached to the top and it's attached to an anchor in the ground. For we'd use a stake or something for a fruit tree. For like a radio tower, you would use a giant concrete block, right? Embedded in the ground. All right, what's this side? Opposite. And what's this side? You all should be doing this yourself. That's your first step, is to identify your sides. Then you have to decide which one of your trig ratios to use. Which one are we using this time? Sine. It's right there. Opposite and hypotenuse is sine. That's what that says. Sine equals opposite over hypotenuse. Xander, you know how to do this already? You should be ahead of me. Yeah, you guys should be working ahead. Now, I'm following along to make sure you're doing it correctly, but you have to try it yourself and maybe make mistakes, but that's all right. Sine equals opposite over hypotenuse, t over 28, yeah? Sine is opposite over hypotenuse. Sine of what? 40 degrees is equal to opposite over hypotenuse. T over 28. Finish it yourself. You're going to multiply by what on both sides? Nope. Look up your sine of 40. 0.64. Really? Is that right? Uh-oh. Better be careful. Remember, the first column is radians, the second column is sine. Y'all see that 60 degrees is about 1 radian? See? It's about 57, 58 degrees for 1 radian. But what's the sine of 40, guys? I'm getting 0.6343. And how are you going to solve that? Multiply by 28 on both sides. And you get almost exactly 18 feet, right? I think it's 18.0 even if you round it, isn't it? Yeah, there's a bunch of zeros there. Feet, again. I did not mean for these to be so close to one another because I was thinking of this, not this. Anyway. Your last part of this problem is yours. You have to find the distance from the anchor to the base of the tree. But don't do it right now. No. You have to use which one? What side is this? Adjacent. And I don't recommend using this one because that's the one you found. You would just be, if you made an error, it wouldn't work. So you're going to use cosine. But don't do it right now. Go ahead and turn your paper over. You can finish this one later. This one is finding an angle. This we have not done before. You need to pay attention, guys. We go through the exact same steps we did before. First of all, read the situation. Got a submarine, depth of 200 meters. The radar or the sonar says that the ship is 1,500 meters away. And at that point, the submarine's destroyed because he turned on his sonar and he gets found. Not a good plan. I'm assuming you don't remember that was in your ear, Serenity? Oh, figured. Yeah, I know. All right, so what's this distance right here? This is 200 meters. Now, how do we know? Well, this is his depth, isn't it? That is the same as this one over here. The distance to the ship to the submarine, direct distance is 1,500 meters. This is our reference angle. Identify your sides, figure out which ratio you need, and figure it out. Go ahead. Work ahead of me. Don't wait. You'll figure it out. Just follow the steps. I promise it'll work. Identify the side, identify the side, identify the trig ratio, put in the substitute, and then you'll be able to figure it out. I promise. It'll work. Mauricio, you planning on doing this today sometime?
What?
Are you going to do this or not?
What do you mean?
The problem, are you going to do it? You're not, you can't do it when you're wandering around. You need to be at your seat and you need to do this.
I already did it.
You did?
Yeah.
What'd you get for your angle?
I don't remember.
Put the phone in here and no, you can't go.
Why not?
Okay, what is this one, guys? What side? Opposite and this one? Hypotenuse. So we're using sine. Guys, it's your test on Friday. It's not my grade. I'd really like for you to get this. Like I said, this is only the very, very first level of applications of trig. There are about 5 or 6 more levels to go. No, we're not going to be doing graphing of like sines, cosines, and tangents. If you look in Miss Dentino's classroom, you'll see some sine, cosine, and tangent graphs. And they're used for all sorts of applications, like signals, electronic signals, like radio signals, television signals. They're all sine and cosine waves. Anyway, this is sine. I hope you got that. Opposite over hypotenuse. Did you put in your numbers? Don't wait for me. It's sine of angle E, isn't it? Sine E is, what is it? Leslie, you planning on getting this? Yeah, but. I know, Yabbit. It's the Yabbits. 200 over 1,500. What decimal is this? Okay, so this is 0.1333 and so on. Isn't it? Take 200 over 1,500, divide it. What do you want is the angle, right? What you have is the sine. So look in your table and find a sine that matches that angle. There's not one that matches exactly, but it should be close to one of them. Between which two angles?
7 and 8.
Between 7 and 8 degrees. You could just estimate it at approximately 7.5. It actually happens to be a little closer to 8. If you look at the numbers, you can tell. We're looking under sine, and we're looking up 0.1333. It looks like this is the closest one, but it's actually in between these. So it's between 7 and 8 degrees, about 7.6, 7.5. Now what this is called it's called the inverse sine. We are doing the opposite of taking the sine of an angle. We are taking a decimal and finding the angle that goes with it. I'm going to show it to you on a calculator. If you look at your calculator, if you look at the sine, do you all see the blue on mine? It's yellow in yours. It says inverse sine. I use the second and the sine, and it gives me inverse sine. And I put in the decimal, 0.1333, and I should get about 7.5. And I actually get 7.66. All right, we have a really dumb monkey. He decides that he sees a tiger down below, and he decided to antagonize the tiger. I don't think he realizes that tigers can climb trees if they're mad enough. I suspect this one may be mad enough when he's done. He's 40 feet up the tree. He thinks he must be safe. He's on his branch. He decides this tiger needs to learn a lesson. This is the angle he wants to throw. This is called an angle of declination. The problem is it's not in our triangle, is it? See the problem? This angle is also the same because these are alternate interior angles. So this angle, the angle of inclination, is the same as the angle of declination on the other side. This will allow us to figure out the angle the monkey needs to aim. So let's see. What side is this? This is the opposite. And this one? The adjacent. So which one are we going to use? Toa, right. So, ka, toa. We're using the tangent. So the tangent is opposite over adjacent. And we want to find our poop angle. Tangent of P is equal to 40 over 75. Find your angle that has that tangent. It's 0.5333, isn't it? Something like that. Yep. And then we take the inverse tangent, or we look up the tangent that has 0.533. And it's really, really, really close to 28 degrees, isn't it? Take a look in your table and you'll find it. Yeah, I would go with just 28. Keep in mind that the monkey is not going to be that accurate. If he is, he's in real trouble. So the monkey is going to throw it about 28 degrees. Now the last question. This is going to be the extra credit on your test, but I'd like for you to get it. I want to know how far is the range? How far apart are they? What would we call this side? What side? This is the hypotenuse. Now, what's really nice about this problem is that there's 3 ways to get your answer. Do you all notice that I already have the adjacent and the hypotenuse? So, and I know the angle is 28 degrees, right? If I use adjacent and hypotenuse, which one am I going to use? Cosine of 28 will work. And the cosine of 28 is going to be the adjacent over the hypotenuse. Now we've got a problem. How many of you remember last week when we had the x in the denominator? Guys? Do you remember what happens when the x is in the denominator? We did it last week with some of the problems. I'll show you which ones. I know, it's been a while. Hang on. Problems like, let me find one that somebody did. Here's one. Last week we did this problem, and do you remember how we had to multiply by the variable to get it to work? Remember this? If you had the variable in the denominator, you have to multiply by it to get it to work out. So what we're going to do, we're going to multiply this by r on both sides. So I'm going to multiply by r and multiply by r. And what will happen is I'll get the 75 by itself. Look up the cosine of 28, guys. So now, how am I going to solve it? What do I have to do now? Divide by what? Do you divide by 75 or the decimal? You divide because I want to get r by itself, don't I? Divide by 0.883. That's the one I looked up for the cosine of 28. And what do you get for r? I get approximately 85 if you round it. 85 what? Feet. Yeah, feet. Now you guys can also, and I highly recommend that you try this yourself, try using the sign and follow the same steps and it will work as well. Now there's a third way to do this. Did anybody notice that we have a right triangle and we know two of the sides? You can find the other side using Pythagorean theorem. So you can take a squared plus b squared is equal to c squared. Substitute it in. A is 40 feet. B is 75 feet. And you can find the r squared. And just take the square root and you can find it. You should get 85 the same way that you did before. Try it yourself. You can do on your test, you can do it this way, or even better yet, do it both ways and you get double bonus. So you can get 5, 10, even 15 points if you do all three ways. No. Oh yeah, the square root on this calculator is kind of a pain. For you guys, it's yellow and it's right above the x squared button. So you do second x squared, and then you got to put it in, 7225, and take your square root. That's going to be 85, by the way. All right, guys, we don't have a lot of time left, so I'd like you to finish this one yourself. Make sure you set it up. Remember, we're looking at this side and that side. So we're doing cosine. Yeah. It's square root. Yep. Okay, guys, turn in your Carnegie stuff and turn in this one. Folks, this is going to be given back to you on Friday, so you can use it for notes. Yes, turn it in today. Finish it up. Hurry up.
Put the Billy Bounce in the beginning.
It's a lot of stuff we did today. You got it. Hopefully got it.
I see you the color.
90. No, actually, 45 plus 45.
Okay, let's go to the bathroom real quick.
We don't have time.
You're doing good.
Only, guys, you have some more time. You need to use it. You need to do number 3. A lot of people didn't do it. Did you do number 3?
No.
Go do it.
Yeah, they're barbell. Mr. I'm in level 7 barbell. You put weight on them.
I see.